Before getting into the definition of Rolle's theorem, I'll give you an example. A car is climbing a hill and descending a hill. It is taking a different route to climb a hill and different route to descend a hill, right? Now, when you see the road, there comes certain points in the road where there will be steep slopes, where there will be steep inclination, steep declination, steep curves, all those things. Similarly, there comes a point where the road will be totally flat. What do you mean by this? The road is totally flat means there is no slope at all. The car will find it really easy to travel on these roads, right? Rolle's theorem is also concerned about such matters only. Rolle's theorem says that there exists a point on the curve where you draw a tangent or a slope. That time the slope will be parallel to the x-axis, meaning to say the slope will be equal to 0. Right? What do you mean by slope again? Slope is nothing but the derivative of the curve at that particular point. Now, keeping this in mind, let us see the definition of Rolle's theorem. Consider a function f tending from closed interval a comma b to set of real numbers r, which is continuous over the closed interval a comma b and differentiable over the open interval a comma b, and f of a is equal to f of b. Then there exists a point c in open interval a comma b such that f dash of c is equal to 0. This is the definition of Rolle's theorem. Before understanding the definition properly, let us see the three criteria that the function should satisfy. The first criteria is that f of x or the function should be continuous over the interval a comma b, and it should be closed interval a comma b. Then the function should be differentiable over the open interval a comma b, and f of a should be equal to f of b. When the function satisfies all these three conditions only, it can be verified for Rolle's theorem. Now, how do you verify for Rolle's theorem? I take a graph over here, and when I have the curve over here again, you can say f of a is equal to f of b. So one condition is satisfied. The next thing, if you see, the function is continuous and differentiable also. Let us take it that way. Now, there exists a point in this curve where you draw a tangent. That time the tangent or the slope of the tangent will be equal to 0, or it will be parallel to x-axis, and that point should be belonging between the open interval a comma b. If you see over here, you have the tangent drawn at point C. C is between A and B. Okay, fine. And the slope of the tangent is equal to 0. Thus, the slope is defined by derivative, right? So, f dash of C is equal to 0. There exists a point in the curve where the slope or the derivative of the function, you can either say slope or derivative of the function, is equal to 0, and C should belong to the open interval a comma b. Then Rolle's theorem is said to be verified.